This is our video for September 23rd lecture. We're continuing with our study of Chapter 8, which is estimating manufacturing costs. Now, if you'll recall from last time, we had our manufacturing cost equations, and in this case, it was this very complicated combination of things that we needed for raw materials and waste treatments and utilities and operating labor and just, well, the cost of manufacturing we're saving for, and then also our cost of our actual facility. And we have an option of doing this with or without depreciation because we'll be studying that in the next chapter. So we have this rather complicated expression, and we have a lot of data that we're going to need. Now, the FCI is what was called CTM, or total module cost, in the previous chapter. And that was our base module cost times 1.18, which added in contingencies and fees. And we can estimate this using that cap cost software or Excel file that was provided with the textbook. What we want to look at today is the operating labor cost, okay? How we'll calculate that. So let's look at the formula for this. Now, not going into how this was derived, but this is pretty much, it seems to work pretty well kind of thing, some logic to it. But what you're going to do is you're going to have this equation. You have to figure out how many solids processing steps you're going to have because they require more manpower. And you're going to need to figure out then how many non-particulate processing steps you're going to have. Okay? And this formula here calculates for you the number of operators that you're going to need per shift. Now, this is for chemical plants and refineries, so it's not going to work for all processes, but it's good for the kinds of processes that you're most likely to go to work for. If you have a lot of solids processing, they just recommend every time you have a solids processing, just add an operator. It will be closer. It's going to just require more manpower. Now, that tells us the number of operators or the operating labor that's going to be required, but how many operators are going to be required to man a shift? Okay, so it comes up that the answer is 4.5. Where do they get that? Well, basically, what we're going to do is we're going to say, well, there's a 52-week year and average 3 weeks of vacation a year. So that's 49 weeks a year per operator. They would work 5 shifts a week, each one of them. Okay, so that means that if you look at this, I'm going to have 245 shifts every year per operator. Okay, that's what we can expect them to work. So 365 days, 3 shifts a day, that's typically what we need, meaning I have 1,095 shifts per year I have to fill. I have 245 shifts per operator per year. Therefore, it's going to take 4.5 operators for every shift that I'm wanting to fill. Okay? So now, let's just look at a little example here. This is the one out of the textbook, and they want you to estimate the operating labor requirements and costs for a toluene hydro dealkylation facility. And this is an example that they've just kind of continued throughout the textbook. As they did this, they have come up with a design that required this equipment. Okay, so a compressor, 7 exchangers, a furnace, 2 pumps, a reactor, a tower, and 4 vessels. Okay, now pumps and vessels, okay, a storage tank, whatever, those don't require really manpower to operate. So I don't need to include those as I'm counting the number of processes. So the number of processes is over here, 1 for each of these with the exception of pumps and storage vessels. Notice that all of these are for liquid, so I have no solids processing, but I have 11 is the number of processes. Now, I'm going to need to figure out how much money it's going to cost. This depends upon where you're located. It depends on what type of industry you're in. You can go to the Bureau of Labor Statistics and find out average wages for all sorts of different kinds of industries. You can even find these regionally. So I took this here for chemical plant and system operators. May 2013 is the most recent that is available. And we find down here the average is $26.31 is what the average operator would make in the U.S. This is a total U.S. average. And you could adjust this if you know that your company pays a little better or a little worse if you need to. But this gives you a good place to get some data. So I've got this. I have no solids processing. I have 11 processing units for fluids. I plug those in and I come up with NOL as 2.97. Alright, 2.97 is how many operators I need per shift. Okay, multiply that by 4.5 to know how many people I really need. I get 13.4. Now here's one of the tricks. You gotta round up. Okay, you can't hire a 0.4 of an operator. And if you only have 13, then you can't cover everything. So you always go up. If it's 13.1, you go up. So I'm going to have 14 operators required times the labor cost, and I just use the annual that was over there. And I come up with $766,000 per year is what's going to be required. Okay, so this gives us a way of estimating what the annual operating costs for labor will be in our facilities. In our next series of lessons, we're going to start looking at the cost of utilities.